The discovery of Neptune, a planet found with mathematics. Chapter 1. The birth of gravity. The story of Neptune's discovery begins centuries before its actual identification. It starts with an apple falling from a tree, witnessed by a curious mind, Sir Isaac Newton. Born in 1643, Newton was a brilliant mathematician and physicist who sought to understand the universe's workings. One day, while sitting under an apple tree, he observed an apple fall straight to the ground. This seemingly ordinary event sparked an extraordinary thought. Why does the apple always fall downward? Why not sideways or upwards? Newton realized there must be a force pulling objects toward Earth. He called this force gravity. Newton's work led to the development of the universal law of gravitation, which states, "Every object in space attracts every other object." The larger the mass of an object, the stronger its gravitational pull. The force of gravity governs everything from falling apples to planetary orbits. This law explained how planets orbit the Sun. The Sun, being the most massive object in the solar system, pulls planets toward it. However, planets don't crash into the Sun because of their forward motion. A balance between gravity and their momentum keeps them in orbit. This principle also applied to the Moon, which orbits Earth. The Moon's motion creates a force called centrifugal force, which counteracts Earth's gravity. Without this balance, the Moon would either drift into space or crash into Earth. Newton's discoveries were groundbreaking. His laws provided a framework for understanding planetary motion. But they also led to a mystery that puzzled astronomers for decades, the strange behavior of Uranus. Chapter 2. The mystery of Uranus. By the late 18th century, astronomers had identified 6 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Then, in 1781, the astronomer William Herschel discovered a 7th planet, Uranus. Uranus was massive, about 4 times the size of Earth. It orbited the Sun at an immense distance and took about 84 Earth years to complete one orbit. However, astronomers soon noticed something strange. Uranus was not moving as expected. Based on Newton's laws, Uranus should follow a predictable orbit. But it didn't. At certain points, it seemed to slow down, speed up, or shift slightly in its path. This was puzzling. Was Newton's law incorrect? For over 60 years, astronomers observed Uranus, trying to explain its unusual motion. Some believed there might be errors in their calculations. Others speculated that an unseen force was pulling Uranus off its expected path. One astronomer, Urbain Le Verrier, proposed a daring hypothesis. What if there was another planet beyond Uranus, exerting gravitational influence on it? If such a planet existed, it had to be massive enough to affect Uranus's orbit. But there was no visual evidence of such a planet. Could mathematics alone prove it? Chapter 3. Discovering a planet with mathematics. Chapter 3. Discovering a planet with mathematics. In 1845, Le Verrier, a French mathematician and astronomer, set out to solve the Uranus mystery. He believed that if Newton's law was correct, he could use mathematics to predict the location of the unknown planet. Using complex equations, Le Verrier analyzed Uranus's deviations. His calculations suggested that another massive planet had to exist beyond Uranus, exerting gravitational pull on it. Based on his work, he pinpointed the exact location where this mysterious planet should be. Le Verrier sent his findings to astronomers across Europe, urging them to search in that specific part of the sky. Most dismissed his ideas, but one observatory in Berlin took his request seriously. Chapter 4. The moment of discovery. On September 23, 1846, German astronomer Johann Galle and his assistant Heinrich de Rest used a powerful telescope to observe the location specified by Le Verrier. To their astonishment, they spotted a large, blue planet exactly where Le Verrier predicted. This was a historic moment. A planet had been discovered purely through mathematical calculations. This new planet was named Neptune, after the Roman god of the sea. The discovery confirmed the power of Newton's laws and marked the first time in history that a celestial body was found using math alone. Chapter 5. Neptune's characteristics. Neptune is the eighth and farthest planet from the Sun. It is a gas giant like Jupiter and Saturn, but its atmosphere is made of hydrogen, helium, and methane, which gives it a deep blue color. Some key features of Neptune. Size: about 4 times the diameter of Earth. Distance from the Sun: 4.5 billion kilometers, 30 times the distance between Earth and the Sun. Temperature: 214 degrees Celsius, 353 degrees Fahrenheit, making it the coldest planet in the solar system. Winds: the fastest in the solar system, reaching 2,000 kilometers per hour, 1,240 miles per hour. Neptune also has 14 moons, the largest of which is Triton. Interestingly, Triton orbits Neptune in the opposite direction of its rotation, suggesting it was captured by Neptune's gravity long ago. Chapter 6. Modern exploration of Neptune. For more than a century after its discovery, Neptune remained a distant, mysterious world. No spacecraft had ever visited it. Then, in 1989, NASA's Voyager 2 spacecraft flew past Neptune, capturing stunning images of the planet. This flyby revealed Neptune's Great Dark Spot, a massive storm similar to Jupiter's Great Red Spot. Voyager 2 also discovered that Neptune has a ring system, though much fainter than Saturn's. These rings are made of dark, icy particles, possibly remnants of shattered moons. Since Voyager 2, no other spacecraft has visited Neptune. However, telescopes like Hubble continue to study the planet from afar. Scientists hope that future missions will explore Neptune up close, uncovering more about this distant world. Chapter 7. The legacy of Neptune's discovery. The discovery of Neptune was a triumph for science. It proved that mathematics could predict the existence of unseen worlds. It also confirmed Newton's laws, strengthening our understanding of gravity and planetary motion. Leverrier, the man who predicted Neptune's location, became one of history's greatest astronomers. Today, a crater on the Moon and an asteroid are named in his honor. His work paved the way for modern space exploration. Even now, Neptune fascinates scientists. Some believe it might have an undiscovered twin, a hypothetical planet 9, lurking in the outer solar system. If so, perhaps one day, just like Neptune, it will be found, not through a telescope, but through the power of mathematics. Conclusion: Neptune's discovery was more than just finding a new planet. It was a milestone in human knowledge, proving that logical reasoning and precise calculations could uncover the secrets of the universe. Even without seeing, we can believe. Even without touching, we can discover. And even without traveling, we can reach the farthest corners of space, through the power of science and